Hello again. We are continuing our discussion of the derivative by talking about how we're going to use that derivative to figure out where functions are increasing and where they are decreasing. Okay, this is lesson 12.7, so let's get started. Let's start with some definitions as to what it means to be increasing and decreasing. So a function is increasing just in general if it's just going up and to the right. It can be curved, it can be straight, but it's going up and to the right. And it's decreasing if it's going down and to the right. So we always read from left to right, so we never talk about it going to the left. So it's either going up and to the right or down and to the right, increasing or decreasing. In terms of derivatives, we need a more technical definition. So a function is increasing over an interval if the first derivative is greater than or equal to 0 for every x in that interval. Now what that means is if I draw a tangent line, that tangent line has a positive slope, or 0 or bigger as its slope anywhere in that interval. Okay? And the opposite for decreasing. A function is decreasing over an interval if the first derivative is less than or equal to 0 for every x in that interval, meaning I draw a tangent line, it's got negative slope for every x in that interval, negative or 0. Now, if I don't want to include 0, then if it was just a greater than 0 or a less than 0 without that possibility of being equal to, then I would call it strictly increasing if it was the first one, or strictly decreasing if it was the second one. So those are the four definitions. So here's an example. I have a function, it's graphed over the domain from -3 to 5, including -3 and including 5. And I want to know over which intervals the function is increasing, over which intervals it is decreasing. So just looking at the graph, I can see that it goes up and to the right everywhere from x equals -3 all the way up to that high point there at x equals -1. And then if I start at that low point where that second blue dot is at x equals 3, it's going up and to the right everywhere from there until I get to the end point at x equals 5. So that's kind of looking at a graph and telling where a function is increasing, and to tell whether it's decreasing, I'm just going to look between those two dots and it goes down and to the right everywhere between those two dots. So that's the interval where it's decreasing, everywhere from -1 to 3, including -1 and including 3. Okay, a sign diagram. If you don't have the graph in front of you, it's a good idea to draw a sign diagram to tell you where a function is increasing or decreasing. So the first thing I'm going to do is I'm going to find the derivative, and I'm going to figure out what values of x make the derivative 0 and which values make it undefined. Okay, and so with those values of x, I'm going to put tick marks on a number line for each of them. Then what I'm going to do is I've created intervals by putting these tick marks on the number line. So anywhere between or outside the tick marks is going to be considered an interval, and I'm just going to take one test value in that interval, plug it into the derivative, and just see whether it's positive or negative. I don't care what the value is, I just care whether it's positive or negative. And then based on that, I'm going to figure out where the original function is increasing and where it's decreasing. So let's go through an example of that. We have f of x equals x cubed minus 3x squared minus 45x plus 9. So let's follow the first step and take the derivative. The derivative of x cubed is 3x squared. The derivative of -3x squared is -6x. The derivative of -45x is just -45. And the derivative of that positive 9 is 0, so I'm not even going to write it. Alright, so if I set this equal to 0, I get 3x squared minus 6x minus 45 equals 0. I can factor that and get 3 times x minus 5 times x plus 3 equals 0. So what that means is this whole thing is equal to 0 when x is equal to 5 or x is equal to -3. So what I'm going to do is I'm going to put the tick marks on the number line for those numbers. Alright? And so now I've created 3 intervals. I've got the interval that's less than -3, the interval that's between -3 and 5, and the interval that's greater than 5. So I'm going to use some test points. If I plug in, let's say -4, into the derivative, what I'm going to get is I'm going to get something that's positive. You could try -5, plug that in there. No matter what x you plug in, as long as it's less than -3, plug it into the derivative and you will get a positive number. Plug in a number between -3 and 5 for the second interval. I usually like to use 0 if I can. If I plug that in, I'm going to get a negative number. I could plug in any number between -3 and 5 as long as it wasn't -3 and as long as it wasn't 5, and I would get a negative number. Okay, and then lastly, I plug in a number that's bigger than 5. No matter what number that is, I'm going to get a positive number when I plug it into the derivative. Okay, so that means the first derivative is positive everywhere before x equals -3. It's 0 at -3. It is negative everywhere between -3 and 5. It's 0 again at 5, and then it becomes positive after x equals 5. So everywhere the first derivative is positive, that's where the function, the original function, is increasing. So it's increasing in those areas that have a plus. So that's everything less than or equal to -3 and everything greater than or equal to 5. And it's going to be decreasing everywhere between -3 and 5. So that's how you can use a sign diagram to figure out where a function is increasing and where it is decreasing. If you have any questions, please let me know, and I will see you tomorrow.